Hello and welcome back to the CCENT journey with me, Ryan. In this next section, we're going to continue with the networking address translation, and this is going to be part 2, where we dive into the configuration required for Static NAT. It's vital that you watch the video prior to this, part 1 of NAT, which is video 39, to get a understanding of NAT and what we're trying to achieve in this video. For those who don't know, you can contact me here on YouTube, on LinkedIn, or Twitter. Okay, so here we are looking at the topology, and as stated in the previous video, we've gone through and I've already configured the interfaces as shown. So for example, we've got router 1 over on the right hand side here, and that's configured as the 172.16.02. And we have this guy in the middle, which is going to be performing the NAT, configured as 172.16.01, and they're part of the same /30, which is going to be our public side. So this is going to be the internet. Again, as I mentioned previously, we are using a private IP range, but we're not too bothered about that. We just want to understand how the NAT translation works. And then on the other side, we have the private area. And the private has a /24 inside the 192.168.0.0 with .2, .1, and then a IP which I think is .10 on the router interface. So before we get started with any NAT and adding some additional complexity to the network, we need to check for basic reachability. So let's go ahead and make sure that the interfaces are in the upstate, and we have some sort of ICMP pings between the devices. Otherwise, if we start adding configuration to the devices and it's not working as expected, we may be troubleshooting the wrong areas. So we go to command prompt on the PC, we'll check the IP address and its default gateway. And we do that using the IP config, and we can see that the right IP has been assigned to this PC, and the default gateway is of course the router itself. So the next thing is, can we ping our default gateway? We can, excellent. Same is true with PC1. Let's have a quick look. So again, command prompt, IP config, and we can ping the default gateway. So that tells us that this broadcast domain is working as expected. And then because we have access to the public side, let's go to the router in the middle and see if we can ping across to router 1. So let's just make that a little bit bigger so you can see it. We're going to go into enable, show IP interface brief. We can see both our interfaces are actually up, and gig01 is the interface we're interested in. With 172.16.02 being the router at the other end. Now the first packet was lost, and that was due to the timeout of ARP. Because remember what we mentioned in a previous video, we had to wait for the address resolution ARP to actually send out that ARP request for a neighbor in order to get that ARP reply to populate the correct MAC addresses for the layer 2 frame. Okay, so now we have reachability end to end, we can start looking about adding the static NAT to this configuration. Now, with static NAT, it's all going to take place on the NAT box. So what we're going to have is the devices of .2 and .1, as it reaches this interface on our NAT box, which is a router, we're going to perform a static translation. And what we're going to do is we're going to statically assign it the IP address here, which is the 172.16.0.1. So first things first is we need to actually enable NAT on the interfaces. And the way we do that is, first of all, we need to go to the inside interface, and we need to tell it that you're part of the inside NAT. So in this case, the inside is going to be the private side, and we do that by using the IP NAT inside command. Now the IP NAT inside command, what that actually does is as traffic comes towards the default gateway and it hits the gig 00 interface, the 00 interface adds another sort of step in the process. So it receives the packet inbound, it looks at the MAC address in the receiving frame and realizes it's for the local router. It decapsulates it and looks at the routing table and so forth. But part of that order of operations, the router now knows that the packet itself may need to go to the NAT process depending on how NAT is matching. So for example, if we have NAT set up for the 192.168.02 and not for the 01, then traffic will come in and follow the normal flow for 01, but when it hits 02, it will see that there's a match statement for the NAT translation and then change something in the layer 3 header. Now if we had another interface off here, let's say it was 10, and this was part of another network with multiple PCs inside of it in a different broadcast domain and different subnet, then this interface here would also have the IP NAT inside command. So we're trying to get any interfaces pointing into the network where the private address space sits to be classed as inside, and we have any interfaces that sit outside where the public domain is referred to as outside. So this means that on the interface of gig 01, we need to do the IP NAT outside. Something worth mentioning, not all your interfaces require the IP NAT statement. Only interfaces to which you're receiving traffic and you want to NAT it. So if I had a third interface that I didn't want any NAT translations to occur on, then I simply won't add the statement command. And if you've added the IP NAT statement command, it doesn't mean everything in that network will be NATed. It only depends on the match statements that you configured through your NAT translation. And that would make more sense when we get onto PAT and we start to understand how we can match networks inside a range, or when we configure one-to-one NAT in a moment and we see that we only NAT one IP at a time. So now we have the interfaces enabled, we're going to go and do the rest of the NAT translation globally. So we'll go into config terminal, into the global configuration, and we're going to use the IP NAT command to fill out the rest of the NAT translation. So we're going from an inside, which is the private, to the outside, which in this case is our public. And we want to do a one-to-one NAT. So we're going to do IP NAT from inside, and it wants to know what the source of the inside is. And in this case, we're going to do a one-to-one static map. And it's asking us which is the inside address. So we're going to do 01. And it's then asking us for the inside global IP address. Now the inside global IP address is actually what we referred to here as the public outside address. So in this case, we need to set it for 172.16.01, and that's the command done. Now inside global, inside local, and outside local and outside global, terms that are referred to in NAT. And you can see here, if we look at the show IP NAT translations, we have inside local. So this here is our private address, which is where our PC sits. And we have inside global, which is going to be the public IP that we change it to. Now outside local and outside global, I don't believe are in the scope of the CCENT, but it is in the scope of the CCNA, I believe. I could be mistaken there. But ultimately, this refers to traffic at the other side of the network. Because remember, from our perspective, we're doing NAT, but so could our destination be doing that. But for now, as far as we're concerned, we only need to really focus on the inside global and inside local. Remember that your inside local is the original private address, and inside global is your public translated address. Now the confusion is inside global is the interface of which we actually configured IP NAT outside. But let's stay on focus and try to understand the basic configuration and verification for static NAT. So now we need to verify, does the translation actually work? And the way we do that is we're going to see if we can ping router 1 on the 172.16.02 from the PC. So let's go into the PC, open up the command line, and we're going to ping 172.16.02 and we get a reply. Now if we go to the other PC and perform the verification on that, let's see what we get. To the 172.16.2, you'll notice it fails. And the reason it's failing is because if we think about what's happening here, we have the two PCs inside the 192.168 network, and we've asked them, please can you try and ping the address 172.16.02. Well, the first thing the PC will do is obviously do the binary AND calculation and realize that the 172.16.02 is not part of the local subnet. So they go through the ARP and they do the address resolution protocol asking for the MAC address of the default gateway. And of course, once they get the MAC address of the default gateway, if they don't already have it, they then create the frame. So they have a ICMP. The ICMP is wrapped inside IP, which is wrapped inside the Ethernet header, which is then sent out onto the wire as ones and zeros. And in here, we have the source being the 192.168.0.1, and then the destination 172.16.0.2, and then the source of the Ethernet header will be the MAC address of this NIC, and the destination will be the MAC address of this NIC, because again we're going to our default gateway in order to get off the local subnet. Now if we have a NAT statement configured on this router and we know one of the PCs currently do, then it will fall into that NAT process, and the NAT will look at the IP and change the actual IP address, and it will change the source IP from what was originally received as the 192.168.0.1, and it will change it to the NATed IP, which is the 172.16.0.1, and send it out. So when router 1 receives that packet and it looks at the layer 2 Ethernet header and decapsulates, it looks at the layer 3 and realizes that the destination was 172.16.0.2, and then it goes up further to ICMP and it goes, oh, I need to reply. So as we know, it changes the source and destination around in the IP header. So the destination now is the 172.16.0.1, and that's because it was NATed, and if it wasn't NATed, then the source would be the original IP. But in this case, it has been NATed because that NAT translation exists, because we created it. And because of that, router 1 knows who to send the response back to, or the reply. That reply then gets sent back to gig01, and it hits the IP NAT outside. It falls into the NAT process, and the NAT process changes it from the 172.16.0.1 back to the original source of 192.168.0.1 and is able to reach the final destination. So NAT is changing that source IP to ensure people in the public domain is able to reach the front door of the NAT box using an IP address inside that public domain. Now, if we go through what would happen if the NAT does not exist, then what we'll see is communication will actually start to break down. Exactly what we just seen a moment ago when we tried pinging the 172.16.0.2 from a PC that did not have a NAT translation. And the reason for that is because when the actual device itself sent the ICMP data and it hit our NAT box looked at the NAT translations and said, I don't have one for the 192.168.0.2. I only have one for the 192.168.0.1. And as such, any traffic from the two will not be translated, and instead, in this case, I will try to route the traffic. So, just like a normal router, it will receive it on this interface, it will decapsulate it, it will look at the IP header, and it will see the destination is part of the 172.16.0.0/30 network. In particular, it's for the 172.16.0.2. So it will switch it to the relevant interface, bypassing the NAT process, and send it out as any other normal IP packet. But the problem comes when router 1 tries to return that traffic. Router 1 will get the traffic and it would go through the Ethernet header and it will decapsulate that. It will look at the IP header and it will decapsulate that, and it will look at the ICMP header and it will decapsulate that. It will then try to rebuild that header, and it will first of all send the ICMP reply. It will populate the IP address and create the Ethernet header. But the problem is with the IP address. The destination is going to be for the original destination, which is 192.168.0.1. In this case, sorry, with the NAT statement not set up, it's 192.168.0.2. And unfortunately, router 1 does not know how to get to that destination. And as such, packets are dropped and they're unable to reach their destination. This is why we need to have NAT. Because if we now apply this to a real world scenario, let's say that router 1 is actually in the internet. This router here is inside our house, and we only know about one public IP, and this is all private. Well, nobody on the internet knows about any of this private space, which means that if we try to route and not NAT, no one is able to get back to us, because we need to remain unique and globally unique with a public IP space for the internet to be able to route back to. But we need some method where we have multiple devices on our network to be able to still use that single public IP, but have multiple private IPs to sit behind. So this is where we would start to use PAT, but it's just another flavor of NAT. NAT will also perform the same. So all your return traffic on all your PCs or devices inside your network going to public services like DNS or YouTube, watching this video right now, you will all be using this public IP address, because NAT would have to be turned on unless you turn off NAT and you have public IPs on the end host inside your network. So hopefully that static NAT translation example gives you an overview of how NAT works different to routing, and it also sets a scene of why PAT is needed. Now, for those wondering, could we have put another NAT statement in place for the second router, or what if we put the root of the 192 network inside router 1? Okay, so just quickly then, let's jump in and have a look at the effect of having a second static NAT translation. So you can see here, there's our first NAT translation. And now you can see in the running config, we have two NAT translations for the .2 and .1. So let's go over to this guy and this guy. And you see both of them are actually now working, whereas previously, and the reason it works is because if we look at the show IP NAT translations, you can see that there are a bunch of translations in the table, but more importantly, if you look at this colon here, these are actual numbers that the NAT translation table, or the NAT box itself, is applying to each translation as it goes out. And the reason it does that is because it needs to keep the translations unique, so it knows where to pass traffic back and forth. So we got two PCs behind the NAT box. We want to make sure that the ICMP responses go back to the correct PC. So you can see that the root is being quite clever there in actually setting up those translations for us. And this is similar to what it does when we get into PAT. Now let's go ahead and remove that static NAT. And you can see the 192.168.0.1 remains and 0.2 is actually gone. So we'd expect this PC to work and this PC to fail. But as I said previously, this is because the traffic's now being routed and not NATed. So if we go to router 1 and we actually solve the routing, let's tell it if you want to get back to the private network, which is that /24, go to the next hop of 172.16.0.1. Then if we go back to that device that was actually failing and try it again, you can see now we have reachability because the box is now routing one of them and natting the other. Okay, so that's all we've got time for in this lesson. Just to go over what we've done, we had a discussion and done the configuration for static NAT. We first off went and verified the topology and then jumped in and configured the IP NAT inside and IP NAT outside on the relevant interfaces. We said that this will be configured on any interface where you want to perform NAT to have any traffic inbound on that interface, sometimes referred to as ingress, to be moved into that NAT process to try and find some sort of NAT match to perform NAT. We also said that if the IP NAT statement is on an interface but there's no global translation, then NAT will not occur. We looked at the global IP NAT translation source static command, where you have the inside local and inside global, which again is your public IP and private IP. We set that up and then done the show IP NAT translations to verify our translation. Now with the one-to-one NAT translation that we set up, we actually done two translations using the same public IP or inside global, and we were able to see that the router itself added numbers in order to keep each session unique. Now you will find that some devices don't allow you to do that. In this case it did, and it was great to be able to see that. When we move on to PAT in the upcoming videos, we'll start to see how that plays a big role in ensuring that we have a pool of IPs on the LAN, let's say a /24, and they can overload onto a single IP using the ability to keep each session unique. Hope this video has been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.